Hello, I'm Mr. Sullivan, and in this video I'm going to show you how to factor out a monomial. Factoring out a monomial is going to be the first step in answering these two Regents questions. First I'm going to show you the long way. Okay, if you can see how to do this without using this method, if you can see which factors can be factored out, you don't have to do this method. But what it means to factor something out is to break it up, basically, right? I break it up through division. Right? If I have a multiplication problem like 2 times 3 equals 6, well, the factors of 6 are 2 and 3. So these terms are a little more complicated. They're not just whole numbers. So if I look at each term and I break it up into factors, y squared can be broken up into 2 times y times y. This next term, 12y, can be broken up into 2 times 6 times y, which can be even further broken down into 2 times 2 times 3 times y. You don't always have to break these up completely to solve these problems. And then the number 54, I'm using the absolute value of that term. I'm using just the term itself, not the sign. That would be 2 times 27, and I can figure that out by just putting it in my calculator, dividing by 2. And I could, if I wanted to, I could break it down even further into 2 times 3 times 9. And if I wanted to go even further, I could break that up into 2 times 3 times 3 times 3. And that would be it. That would be 27 times 2, which is 54. What I'm really looking for here, though, is what they have in common. And if I look at this, they all have a 2. Every single one of them has 1, 2. Of course, this expression has more than 1, 2, but it doesn't have a y, right? So this is what they have in common. So this then is a factor, because we're thinking about we broke these numbers up, right? If I'm trying to figure out what two expressions multiply together to give me the given expression of 2y squared plus 12y minus 54, I know that I could multiply 2 times something to get me back to my original expression. Turns out, using this method, it's just the leftovers. Y squared is all that's left over, y times y. And you check here, right, this y times y times this 2 gives us the original term right here. So if I think about the distributive property, 2 times y squared would give me 2y squared. We're basically undistributing, right, what happened here. We use the distributive property to get here, right, but this is what we're given, so we're undistributing it. So now, the only thing that's left over here is 6y, so I would just put in 6y. And sure enough, 2 times 6y is 12y. Minus the leftover here, which is 27. You can always check in your calculator. 2 times 27 is 54. So now we've factored out this monomial right here, this 2, that one term. The next one looks a lot more complicated. But I know something, right? I know that 9 is divisible by 3. So I'm thinking to myself, oh, there's got to be a 3 in here somewhere. But I'm also noticing that each of these share an x. So when I break this one down, we can do it like this. In the next term, we can break up 33x squared, like this. And then 90x could be broken up like this. Right, because 3 times 30 would give me 90. Now, this 30 could be broken up even further, but I don't need to do that because I see that the only whole number here is a 3. Right? So they have that 3 in common. I don't need to break this 30 up anymore. This is what's going to be left. But this problem is a little bit different than the first one because they also share an x. So that means my common factor, the greatest common factor here is 3x. So this expression, 3x to the third power minus 33x squared plus 90x is going to be equivalent to 3x times these leftovers, right? What's left here? X squared. And 11x is left here. So I follow these signs, so it's going to be minus the leftovers of this expression. Sorry, it's 11x, right? That's what's left. And then the only thing that's left in this last expression of 90x, when I factor out 3x, is the 30. So we would say plus 30. And I can check this by multiplying it out. 3x times x squared would give me 3x to the third. 3x times 11x would give me 33x squared. And then 3x times 30 would give me 90x. And I apologize, I forgot to put that x in there. Let's just correct that little mistake. And these two expressions are equivalent. In the next couple of videos, I'm going to show you that we actually can factor these trinomials here. Because if you notice, right, these are not factored completely. This answer choice is not provided here. This answer choice is provided here, right? Because they put that in there to confuse you. However, if we factor this expression, then it would be factored completely, which is what we want to do. We want to make sure you guys learn how to factor this completely. So please watch the next few videos so you can learn how to factor trinomials.